Alright, you guys, so you should be looking at a slide that talks about intercept form. So this is where we left off yesterday. So in the past couple sections, we talked about vertex form and standard form, and then intercept is the last one. So there's just 3 of them that we have to learn. So we know the first 2, and then this third one is intercept form, and this is using your x-intercepts, hence the name. So the equation for it is going to be f of x is equal to a, and then parentheses x minus p, and parentheses x minus q. And then what all those letters stand for, your a is going to be that vertical stretch or compression. So whatever the a is going to be a number out front. You might not have an a, then it would just be 1. So it wouldn't be stretched or compressed. But yeah, so your a is going to be, if it's a number, it's going to, if it's a actual like a whole number, it would be a vertical stretch. If it's a fraction, it's going to be a vertical compression. And it also helps determine if our quadratic is going to be opening up. So if like the U shape is opening up or if it's opening down. So if it's a negative number, we know that the negative makes it reflect across the x-axis. So then that would make it open down. If it's a positive number, we know our graph is going to go open up. Okay, so just remember, so positive should look like this, negative should look like that. Okay. And then the P and the Q, what those stand for, those are just going to be the numbers of our x-intercepts. And the thing is, so if it gives you your x-intercept, we talked about yesterday when we were solving them out, that they're always opposite. Everything in the parentheses is opposite. So if I said you have an x-intercept at 2 and 3, so I tell you you have 2 x-intercepts, one's at 2 and one's at 3. So if you're writing the equation, when you put them in the parentheses, you need to use the opposite numbers. So the positives would become negative, the negatives would become positive. So you would have x minus 2 and x minus 3 as your parentheses, okay? So remember, everything with parentheses is going to be opposite, okay? Okay, so then the last slide is just a couple examples using that. So if you guys want to go ahead and switch over to that last slide. This one, it says, write the equation of a parabola in intercept form. So we're trying to write our intercept form, which we just said was f of x is equal to a, x minus p, and then x minus q. Okay, so that's my intercept form. It tells me that I have 2 x-intercepts. One of them is at -2 and one is at -1. So I have 2 x-intercepts, one's at -2 and one is at -1. And then it also tells me it passes through the point -320. So the reason that it gives you an extra point is because what we're going to do with that is we're going to plug it in for our x's. So you're going to plug the x value in twice, and then you're going to put the y value in and solve it out for a, because you need to figure out if you're vertically stretched or compressed, or if you come up with a negative number, you know you're reflected. So that's why you get that extra point. Okay, but we can start by putting in our x-intercepts. So because it's at -2, I'm actually going to put +2. Okay, so I would have x plus 2. And then for my other one, I would have x plus 1. And if it helps you, you can think, so this is my equation. So if you were to put in, so your equation is x minus p. Well, your p value is -2. So if you were to put x minus -2, you know that that becomes a positive, which is what you need, okay? So if you plug just your number in for p and q, the minus, if you just keep your minus, it's gonna make it all work out algebraically, okay? Because you'd have x minus p, so x minus -2 is x plus 2, which is what we need, okay? Or you can just remember that they're opposite, okay? All right, so then we have this f of x still, and then we need to go ahead and solve for our a value. So to solve for a, I have this point -320. Well, I'm going to put the -3 in for both of my x values. So I would have a times -3 plus 2, and then -3 plus 1 is equal to 20. Okay, so that would be it all set up. So now the only variable that I have left is a, so I want to go ahead and solve this. So remember, do order of operations, so you want to do what's in your parentheses first, and then all of this is just multiplied together because there's no addition sign, no subtraction sign, like it's all just like smushed together, so it's all multiplied. Okay, so we have -3 plus 2, which is going to give me -1. And then -3 plus 1, which is going to give me -2. And that's equal to 20. Okay, so now all of this is multiplied together. So a times -1 times -2. Well, I know that -1 times a -2 would be a +2. So I'm going to have a +2a, because those are, the a is multiplied by it as well, is going to be equal to 20. So now to get a by itself, I can go ahead and divide by 2, and I get my a is going to be equal to 10. Okay, so then once you have your a value, that was the last thing, you can then just write your equation. So if I were to write my equation in intercept form, all I have to do is plug this 10 back in for my a, and you should always, at the end for every equation, you should have your x's and your y's still, so don't have it filled in with the numbers, okay? So you would have f of x is equal to 10, and then x plus 2, x plus 1 would be our equation of that parabola in intercept form. Any questions on that first example? All right, let's go ahead, let's move on to the second one. We're gonna do the exact same thing, but just a little more practice. This time, I have x-intercepts at 3 and -3, and then my point is at 1, 2. So here's our information, what we start with. So I have one x-intercept at 3, one at -3, and then my point is at 1, 2. Okay, so I'm gonna use this intercept form again to start off. So it's the f of x is equal to a, and then x minus p, x minus q. So now I'm going to go ahead and plug in my two x-intercepts for my p and my q. Okay, so if I do that, I have f of x is equal to a, x minus a +3, so it's going to be x minus 3. So that's opposite of what it is. So +3, now it's in parentheses, so it's opposite, so it's the -3. And then I have x minus -3, so x minus a -3 is going to be +3, which that's opposite of what it was. Okay, so I have x minus 3 and x plus 3. Now from here I can use this other point, the 1, 2, so I can plug in, so the x is 1, so I can put in 1 for both of my x's, and then my y value is 2, so I can go ahead and plug in 2 for my f of x. So I'd have 2 is equal to a, and then 1 minus 3, and 1 plus 3. So now we just need to solve this. So remember, start with what's in your parentheses. So 1 minus 3 would be -2. And then 1 plus 3 is going to give me 4. And then it's still equal to 2, and I still have that a. Now all of this is going to be multiplied together. So 4 times a -2 times a is going to give me -8a. So I have -8a is equal to 2. Now to get a all by itself, I can go ahead and divide by -8, and I end up with, when I simplify it, I'd have -1/4 is equal to a. Okay, so I find out that my a value is -1/4, so that's going to tell me, because it's negative, that my graph is opening down, so it's going to be like a parabola like this, opening down, because it's reflected over the x-axis. And then because it's a fraction, I noted that it's going to be vertically compressed. Okay, so it's going to be kind of like shrunk down, like all compressed together. Okay, so then last thing, I would just need to write my equation. So to do that, I just need to plug this a value back in, And then my equation should always have the f of x and the x's, so don't have numbers there. So I would have negative 1/4, and then x minus 3, and x plus 3. Okay, so I'm gonna stop the video and then ask you guys if you have questions.